question 1D, which asked us to express a function, a given function, as a Maclaurin series using sigma notation. So we're asked for a Maclaurin series. That means the center of our series is 0, and we're asked to use sigma notation. Now, importantly in this question, you will be given a function that is a product of two individual functions. So it's very important to observe here that you do not want to compute your Taylor coefficients for the function as a whole, because in doing so you will compute derivatives of the function, and every time you compute the derivative of this whole function, you will use the product rule, and thereby at every successive differentiation step obtain more and more terms. So you don't want to do that. What you want to do is you want to compute the Maclaurin series for this factor here, e to the x first. Your other factor is already a power of x, namely x to the 1. So the thing to do would be to compute the Maclaurin series of the e to the x factor first. Then at the end, you'll multiply through the whole series by x. In other words, each term of the series by x. So instead what we'll do is let's define a new function being e to the x. So let's let g of x be e to the x. That's this factor here in our function. We'll compute the Maclaurin series for this function, then at the end we'll multiply through by the power of x that we're given. So let's remember the general form of our Maclaurin series. It's a Taylor series about x equals 0. So we'll say our g to the x here will be g at 0, the center of our series. That's the first term in our expansion, plus g prime at 0 times x. So x minus 0, 0 being the center, so just x, plus g double prime, the second derivative evaluated at 0, on 2 factorial times x squared, and so on. So what we need here clearly is a number of derivatives to substitute into our expansion. So that is the Maclaurin series we're looking for. We simply now need to find these Taylor coefficients. So let's do that by finding a few derivatives. So g of x we're given, that's e to the x. So g at 0, so e to the 0 is 1. Now what's nice about e to the x is that all derivatives are identical. So g prime of x will likewise be e to the x. So g prime at 0 will again be 1, and so on for derivatives of all order actually. So g to the nth derivative of g will again be e to the x. So the nth derivative evaluated at 0 will likewise be 1. So we'll substitute now into our expansion. So g of x will be 1 plus 1 times x plus 1 on 2 factorial times x squared plus 1 on 3 factorial times x cubed and so forth. So in sigma notation, g of x, e to the x, is the sum from n equals 0 to infinity of x to the n on n factorial. So far I've computed the Maclaurin series of this factor here, e to the x. Now to get the Maclaurin series for the function I was given, I will need to multiply this Maclaurin series through by x. So therefore, x e to the x will be this series multiplied through by x. So we'll multiply every term in our series by this common factor x, and so that will give us the sum for n equals 0 to infinity of x to the n times x, which is x to the n plus 1 on n factorial. So that is my Maclaurin series for x e to the x in sigma notation. All right, thank you.